All right, so again, maybe you are not sure what the heck is going on yet, but same process as we did last week, right? Let's draw our barrier, right? Draw that line. What do we want to put in the same tree, right? What do we want to put in the same tree? This 2z and this z. Notice how they're on opposite sides of the line, so I need to do inverse somewhere. Y'all like your x's on this side, your variable on that side, so that's fine. We'll move it to this side. So this is a positive, which means I'm going to subtract it. How many z's is that? It's 1. So I'm taking 2, I'm minusing 1, and what does that give me? 1z. Everything else, that plus 2, that positive 60 is going to stay. And again, from here, you should have no issues with solving that equation. None. So what would you do next? Minus 2, that goes away. That's 58. That 1z is still there. So you can divide by 1 if you want, but it's still going to be the same thing. So z equals 58. That's it. That's all we're doing. All right? I want you to try at least a little bit for number 3. Try it and then come back. Welcome back. You should have drawn your barrier. This 9b wants to be with this. So I'm going to move that over here, meaning, I'm sorry, that 0.9b. So I subtract it. That goes away. And then I'm just going to use a calculator, right? Because our negatives are sometimes a struggle. If you got it, that's fine, but some of us are still having trouble. So we have negative 2.6 minus 0.9, and that is negative 3.5b. I still have a positive 4, and I still have a minus 17. From there, we should have no issues. Minus 4, 17 negative minus 4 is negative 21. I still have my negative 3.5b. Going to subtract by negative 3.5. And b equals 6. Okay? While 4 looks different, right? While 4 looks different, I want you to still try it. I promise it's not as bad as it looks. Welcome back. So we should have moved our 2y over to our 3y. So minus 2y here, minus 2y here. 3 minus 2 is 1y. And then we still have our 50. You can divide by 1 or you can leave it. Doesn't really matter. But y equals 50. That one wasn't bad at all. That one wasn't bad at all. All right. Last but not least, Cynthia earned $680 in commission and is paid $10.25 per hour. Javier earns $410 in commissions and is paid $12.50 per hour. What will you find if you solve for x in the equation? So again, this right here, that right there is Cynthia's, and that right there is Javier's. So we basically are looking for when are they going to be the same. So y'all keep asking me, Ms. Sherman, when are you going to use this in the real world? This is the real world, right? How many times do y'all look at each other and you think, well, how many shots did you make? How many shots did you make? And you're trying to compare each other, right? How much money do you earn? How much money do you earn? Like, at what point are we going to be the same? That's math in the real world. This is it, okay? So it's the same process. Do that. I want you to try to solve this one. Welcome back. So we should have subtracted 12.5x from both sides. That goes away. 10.25 minus 12.5. It's negative 2.25. We still have our plus 680. We still have our 410. And then we are going to subtract 680 from both sides, or you should have. And 410 minus 680 is negative 270. And then that's negative 2.25. Ooh, I forgot my x. So sorry. So sorry. Divide by negative 2.25. So x equals 120. So after 120 hours, they will be paid the same amount. All right. So again, the focus of today was solving equations where a variable is on both sides of the equal sign. Don't worry if you're still a little bit confused. We are going to work more with this the next couple of days in class.